So the last set of equations that we're going to work on for exponential equations, they're just ones that deal with fractions. It may be hard for you to tell, but there should be a negative sign. Right here, there should be a negative sign. It may be hard to see in the printing that, it's real small, but there's a negative there, so give those ones a try and see how you do working on fractions. Good, so some people seem to already have an answer there. 16 and 8, what did you pick to represent? You got to be able to figure out something that'll work for both. What did you pick as a base? Yeah, 2 is a good one. So 2 makes a good base. This could be rewritten as 2 to the negative 4. And this could be rewritten as 2 cubed. So that'll be 2 to the negative 4x equals 2 to the 15 minus 3x. So this is the equation that I have to solve. And that's going to be negative x equals 15. So I think, did anybody else get negative 15? Yeah, okay, thank you. How about 27 and 81? How am I going to relate those two together?
3.
Yeah, 3 is the number that we're probably most likely to pick. So 27 can be rewritten as 3 cubed to the x minus 2. And 81 can be rewritten as 3 to the negative 4. So, sorry, I'm actually skipping a step here. Maybe I'll go one step. Some of you might be able to jump a step like that, but just in case, I could rewrite this as 3 to the 4 to the x plus 3. And this will be 3 to the 3x minus 6, 1 over 3 to the 4x plus 12. So then I'd have to, before I can, drop the bases and just work with the exponents, I'm going to have to move this to the top. So I do that by taking the negative. So what's going to happen is that exponent on the right side is going to become completely negative. Okay. And that's the same as flipping that fraction or taking its reciprocal. So the equation that I get when I'm finished here is 3x minus 6 is negative 4x minus 12. So 7x equals negative 6. And x equals negative 6 over 7. Okay. Number 9 is kind of a challenge. How are we going to relate 125 over 216 to 6 over 5? Any ideas? Sure, Jackie?
You flip it and change the base.
Yeah, so one thing you might notice here is you might say to yourself, well, I know how 5 and 125 are related. You might even say, oh yeah, and look, 6 is 216 can be related as well, but they're upside down. So what we can do is, there's that negative sign there. It's actually going to help us out. Because now that I flipped the fraction, okay, negative is back to positive here for the exponent. And 6 over 5 to the 3x minus 3. So, we're working with cubes here. This would be 6 over 5 cubed to the x over 4 equals 6 over 5 3x minus 3. And that's going to give me 6 over 5 to the 3/4 x equals 6 over 5 to the 3x minus 3. So 3/4 x equals 3x minus 3. So if I move these around here, let's see, oh yuck, fractions, so that'll be 12 out of 4. So this will be negative 9 over 4. Is that right? Negative 9 Oh, let's not do fractions. I'm feeling lazy. I'm going to multiply by 4, and that way I won't have to work with the fraction. Let's go 3x equals 12x minus 12. So I basically just multiplied both sides by 4, and now I don't have to deal with that fraction. So this will be negative 9 equals negative 12. So x equals 12 over 9, which is 4/3. Running out of room, but hopefully you can see that for your notes. Any questions so far? That is the Mount Everest, meaning you've hit the peak. That's the end of it in exponential equations. Just for your own reference, these two here, I would say these two are more than fair as far as what would show up on a provincial exam. This one here, however, that's like an all-star question. So I certainly wouldn't expect to see that on your provincial exam. But if you can do it, that's great. It just shows that you're real comfortable with the technique. Okay, but you should definitely feel like you can do the first two here at this difficulty level. Okay, so there's one other item that appears in some of the equations we solve, and that's with rational exponents. So I'll show you what I mean here. For example, we have this equation x to the 3/2 equals 8. Like, how do we get around solving that? Well, one trick to doing this is to raise both sides to the reciprocal. So for example, if I had x to the 3/2 and I raise it to 2/3, I have to do the same thing to the other side. Otherwise, I don't have the equation anymore. But what happens here is this exponent law is multiplication. So it becomes x to the 1 equals 8 to the 2/3. Can anybody do 8 to the 2/3 without a calculator? Yeah, 4. How'd you do it?
I guessed.
You guessed. Well, I hope you're that fortunate on our unit test. Anybody have can anyone explain how this works? Sure, Alan.
You square it and you root it by 3.
Yeah, so you could do it a couple ways. One is you could square it. So the top is the exponent. That would be 64. And then what's the cube root of 64? So this is the root. Oops. This is the, let me just undo that for a second. This is the root in a fraction, and this is the exponent. Now personally, if I don't have a calculator, I like to do the root first, so the number becomes smaller, and then I do the exponent, because that way I'm working with smaller numbers. So anyway, this could be rewritten as the cube root of 8, which would be 2 squared, which is 4. So the trick here that we'll work with is when you encounter something like this, you're going to raise both sides of the equation by the reciprocal. So here's a couple of other ones. See how you do. This one is even trickier to see the negative sign. There actually is a negative. I don't think you get a nice number unless you, it's hard to see it. I guess it was too small before it printed. There's a negative there, but to make sure you get a nice number, keep the negative in it. Okay, so I'll let you try those two, and we'll recap together. So I know it looks like most of you are finished the first and working on the second, so I'll take a break just after I do this one. So x to the negative 4/3, we're going to raise it to the negative 3/4, and that means I have to do the same thing to the other side here. So now what I've got then is x equals 81 to the negative 3/4. Sorry, 1 over 81. I'll draw that a little nicer. Let's make it 1 over 81 to the negative 3/4. Okay, so the negative sign will be nice. That way we can flip this. It'll become 81 to the 3/4. Okay, So can you do that without a calculator?
What's that one?
27, yeah, good. So if you had it, what's the root that I'm looking for? 3 or 4?
4.
Yeah, 4 is the root. It's on the bottom. So I think of it like a tree. Roots are underneath. So 4, the fourth root of 81, this is going to be 3 cubed. And then there's only the cube to do left, so it's 27. Okay? So x equals 27 in this one. I'll give you a couple more just to try the next one. Okay, so again, if I was faced with this, what I'm going to do is raise this to 2/3, which means I have to do the same thing to 27. I'll end up with 3x minus 6 equals 27 to the 2/3. So this is the cube root of 27. That's 3. So 3x minus 6 equals 3 squared. So that's going to be 9. So 3x minus 6 equals 9. 3x equals 15. So x equals to 5. Okay, so I believe if this was something you encountered, hopefully you'd have a calculator to help you do those exponents with fractions. But if not, it should be pretty simple for you to figure out. They'd be small numbers to work with. Okay.